Morning, everyone. We're gonna wait another minute or so. 10 o'clock. We're gonna make sure. Looks like maybe about 2 minutes, and then we're gonna kick this off. Just wait for everyone to log in still. So thanks for joining us this morning, and just give us another minute or two. All right, so it's 10 a.m., so I think probably should just get started. So good morning, everyone, and thank you for joining us for another episode of our 20-minute webinar series. This episode will be on Legionnaire's prevention beyond the tank. We all know that Legionnaire's disease is a major and very real concern, but many people only think of it as a cooling tower issue or in your domestic hot water storage tanks. We want to remind everyone that it can thrive and grow beyond the tank as well in your domestic hot water distribution piping. As a reminder, be sure to submit your questions throughout the webinar and we'll address them at the end. At the end of the webinar, we'll also have a survey where you can let us know if you'd like to be contacted on this topic or any other. We don't want to bother everyone who attends unless you're interested in furthering the conversation. And if you have any questions at all, you can reach us at our phone number above or at support@rathoshost.com. And also there are handouts available for download, so please be sure to grab those. This week's webinar, we have the pleasure of having Cody Mack from Calliope Hydronic Solutions to give us our presentation. Many of you may know him from the very popular Coffee with Calliope webinar series. And if you have a thirst for knowledge in our industry, I seriously urge that you check out their webinars. They are top in class. As a reminder, this series will only be about 20 minutes of presentation. From our personal experiences, we know that an hour of detailed information can be challenging to focus on with our busy lives, so we decided to follow with the TED Talks concept of shorter presentations. They actually do 18 minutes or less. The idea here is to give you a high-level overview of some problems and solutions to get you thinking. And after that, we'll address any questions you have on the topic to dig deeper into the questions that you actually have. And again, this being a high-level overview, there's a lot of detail that we'll blow past. So it's my suggestion that if you reach out, that you reach out to us if you have any interest or questions, and we can schedule a one-on-one with you and your team. Our phone number and email are at the bottom there. After the 20 minutes, Rath Associates wants to do our part to help the first responders and worthy charities who are doing a lot during these uncertain times. We've already given away $1,500 and are looking forward to continuing the mission. We'll send out a quick poll to get your input on which charity you'd like us to donate the $500 to this week. After that, we'll get right back to the Q&A. So without further ado, let's just pass this on to Cody. And here we go. I'm going to give him access to the keyboard. And
perfect. Well, thanks, Greg. If you can just bring up my slides there, that would be great. And again, my name is Cody Mack, and I appreciate your guys' time. I am a training and education manager with Calliope North America. And like Greg said, we wanted to talk about Legionella and Legionnaire's disease and how you can help take care of that and kind of mitigate the issue in your domestic hot water distribution systems as well as the tank. And you know, just kind of give you some problems and solutions that you might run into on jobs that you can hopefully take care of, and then go over some products that we might have to offer you guys to make that happen. So in short, Legionella is not a new topic, but it seems to be more and more popular as days go on here. We're seeing more and more cases. And it's something that you can't really overlook anymore. And so Legionella is a bacteria that you're going to find typically in warm, stagnant water. That's where Legionella bacteria wants to not only survive but thrive, and it's an issue not if you drink the water, because drinking water with Legionella bacteria and it is not really much of an issue, but if you do have it. If it's in a vapor form and you actually breathe it into your lungs, that's where it becomes a big issue. And that's, Greg already mentioned it. Cooling towers are a huge source of Legionella bacteria and Legionnaire's disease outbreaks and things like that. But it can still happen in your domestic hot water distribution systems as well. So, you talk about showers, all the body spray showers and everything else, and even like just steaming up a bathroom and things like that. It can definitely be cause for concern. So, like I said, definitely something you're seeing more and more of, and let's just talk about some solutions here. There we go. So when you look at a lot of the solutions that are out there, they're typically going to involve either chemical injection of some sort, whether it be chlorines or monochloramines or something to that effect. There's also solutions out there like copper silver ionization, as well as the ultraviolet and ozone type scenarios as well. And what I want to get the point across with a lot of these solutions that are out there on the market is that they're typically very expensive, and I'm all for buying or using the correct product for the application, even at whatever cost might be necessary. But I think in a lot of these cases, they're not necessarily 100% needed, and because of the fact that they are very expensive, not only to purchase up front, but to take care of for the life of the building, for the life of the system. If you've got, say, for example, a chemical injection system, you have to be providing chemicals for the life of that particular system, and not only that, maintaining it for the life of the system, and repair parts and everything else. And so there's a lot of commitment involved with a lot of these, and not only commitment as far as costs, but space too, for that matter. Most mechanical rooms aren't getting any bigger these days, and it's something that I hope that we can help you to avoid if you can. So we recommend a process called thermal disinfection. Thermal disinfection is the idea that this high temperature water is going to be able to kill off that bacteria, and that's exactly what happens with Legionella bacteria, is that you can use that high temperature water to kill it off. So let's look at the next slide here. Under most normal scenarios here, you've got a domestic hot water source, and you've got your domestic hot water distribution system, and you've got your recirc coming back and everything like that. The idea here is that under most scenarios, your entire domestic hot water distribution system is going to be right in that sweet spot where that Legionella bacteria, like I said, not only can survive, but it wants to thrive and proliferate and everything else. And so with that in mind, the idea of bringing up that temperature, you can see the chart over here on the right, by bringing up that temperature, you do have the ability to kill off that bacteria, okay? Now, this is a process that's already being used in the European market. It's just not something that we've seen here a whole lot. I mean, it's been in use in the European markets for over almost 2 decades. And so with that in mind, I mean, you look at this, 130 degree water, yeah, it can kill off bacteria, but it takes a long time. You move up to 150, it can kill it off in a couple minutes. 160, instant kill. And that's the idea here, is that you're taking that high temperature water, and obviously, you can use that high temperature water to kill off in your storage tank, but by distributing it out through the network and bringing it back, you have the ability to clean out that distribution system as well. And I understand, and I talked about the idea that chemical injection and some of these other equipments that are out there have their downsides. There's obviously downsides to high temperature water too, and I'll get to that in just a second. But I also want to impress on you the fact that the Safe Drinking Water Act if you are injecting chemicals in that system, the Safe Drinking Water Act says that if you have more than 25 occupants in that building, you actually become liable for the water quality. If you're adding any more chemicals to that building than what is being provided to you by the municipality or wherever you're getting your water from, that makes you responsible for those occupants and the health and safety of the water that they're drinking, or using in their tubs or whatever the case may be. So that's another big thing. I mean, with today's age of lawyers and lawsuits, obviously you want to avoid that. Now, obviously, if you do take, and distribute high temperature water throughout your system, you do need to make sure you're protecting the occupants in those buildings, protect them from scalding. A lot of times everybody says, 160 degrees, holy cow, that's way too hot. You're going to hurt somebody. And that's obviously, the case. You don't want to be washing your hands with 160 degree water. So point of use mixing valves, like our little under sink mixing valve here, are going to be the way to go. You need to make sure you have anti-scald protection at the fixtures, or a 1016 temperature based shower valves and things like that, or thermostatic based shower valves. Just to make sure you're protecting those occupants in the building. This is a new product that we actually just brought to market about a year ago. Really cool little 4-port valve, comes with a nice little bracket. We do a lot of injection molding. You might know Caleffi is a brass manufacturer, which we certainly are, but we do a lot of injection molding as well. Really, really cool little product here that we brought to market. So, you want to protect those occupants if you are doing thermal disinfection to kill off that bacteria. And this is one way you can do it. And obviously, there's other manufacturers out there as well, but I just wanted to kind of highlight a nice little product that we brought for you guys. So from there, thermal disinfection, there's always a lot of questions about it. The idea of it is very confusing to a lot of people. Like, how do you control it? How do you ensure that it happened, that it completed the thermal disinfection process? Thermal disinfection, obviously you need a domestic hot water source, which you're already going to have. You're going to have your distribution system as well. But what you're also going to need is some kind of controller with a logic that can actually handle this whole process. And that's where our LEGIOMIX comes into play, which I'll talk about in another slide, but you can see it there on the right. But you're going to need some form of an electronic mixing valve. And this is where I think a lot of electronic mixing valves are making a lot of big strides against the thermostatic counterparts. Now, as a company, we make thermostatic mixing valves. We make electronic mixing valves as well, and I think they all have their place. But we're seeing more and more electronic mixing valves in especially the commercial markets going out there. And so like I said, with thermal disinfection, you're going to need an electronic mixing valve with some type of controller with that logic to complete that. Now, in the European markets, usually they're jacking up that temperature to about 160 degrees. They're maintaining that distribution temperature out through the system for typically 15 to 30 minutes. It really depends on the size of the building and how long it takes to get back. With our particular product here, we also have the ability to verify that the thermal disinfection cycle has been completed with the use of a sensor on the recirc return. And basically, with that sensor, we're looking for a specific temperature for a specific duration of time, and that is something that like I said, we can then confirm that you can actually complete that thermal disinfection process. Now, the things you need to watch out for with thermal disinfection is you need to circulate as much of the system as humanly possible. And as engineers, designers, installers, things like that, you guys are all well aware that you're trying to keep your dead legs as minimal as possible, as small as possible. And there are codes in certain areas where they say you have to be no more than 2 feet away from the fixture with your recirc tapping, or a certain amount of time to get it there, depending on what you want to do. But the idea is you want to completely get rid of dead legs as much as possible. And I mentioned it before, the idea of anti-scald protection, ASSC 1070 type mixing valves, or like I said, the 1016 thermostatic type shower valves, things like that, to make sure that you're protecting those occupants if you are doing thermal disinfection. But in the end, you're going to get a lower upfront cost and a lower lifetime cost for that building, because you're already using products that you already have on site. You're using that domestic hot water source, the domestic hot water distribution system, and you're making it work, and without adding any more chemicals or any more equipment into the mix. And once that thermal disinfection cycle, that 15 to 30 minute cycle is done, then you can bring down the storage tank temperature. You can bring down the distribution temperature as well. And like I said, with our LEGIOMIX, you can see on the right there, you have the ability to control all that with that LegioMix control, which I think is really, really cool. So now obviously, mixing valves as a whole are definitely a big necessity. A lot of times people kind of scoff at the idea of using mixing valves in their jobs because it's just one more thing that can go wrong and whatnot. So, the idea of mixing valves is to make sure you're providing a consistent and safe temperature out to your occupants. In a lot of cases, whether it be a small little 40-gallon residential tank or hundreds of gallons of storage in a large commercial building, these aquastats or sensors or whatever, they're all going to have a differential or some form of hysteresis, and they're not always going to have the exact temperature all the time coming out at 120 or 125 or wherever you're looking at it. You can have 10 or 20 degree temperature swings, and that's where I think mixing valves really help the cause by making sure you have, like I said, a very consistent temperature coming out of that domestic hot water source to make sure you're protecting those occupants, and it's something that they're accustomed to, so that way they're not getting really hot sometimes and really cold other times. Now, speaking of really hot water sometimes, again, I wanted to talk about problems and solutions. And I think recirc creep, if you've never heard the word before, I'll explain it in a minute. I think recirc creep is probably a bigger problem than most people realize. This is probably an issue that you've already dealt with on a job. You just didn't know how to name it or how to put your finger on it in a lot of cases. And the idea with recirc creep is that if you are running a constant recirculation system in a building and you're using a thermostatic mixing valve, it doesn't matter if it's our mixing valves or anybody else's, you can actually run into scenarios where your distribution loop and your recirc line will come up to whatever the storage tank temperature might be. So if you're running 150 degrees in this storage tank, you actually have the ability to bring up this distribution line and your recirc line all the way up to 150 during times of no demand. And the reason why that happens is you look at this very simple drawing here. Obviously, you've got your recirc coming back, and the mixing valve is sending out 120 degrees. Your recirc's coming back maybe at 110 or 115. So you've got 110 or 115 coming into the cold inlet, and then you actually have it reverse flowing here, going back through the tank, and then all the way around back to the hot inlet. And the biggest issue is that most thermostatic mixing valves do not have the ability to completely close off the hot or the cold inlet. And if you don't have the ability to completely close off the hot inlet specifically, you have the ability to add more heat to the loop than what the loop is giving off. Okay, and that's what's referred to as recirc creep, is the idea that temperature is going to creep up. And if you have a long enough time of inactivity, typically overnight, when nobody's washing hands, taking showers, things like that, you have the ability to bring up that entire distribution system and the recirc line all the way up to whatever is being stored in this tank. So the first person that turns on that faucet in the morning has the potential for scalding, and then all of a sudden the mixing valve works great for the entire rest of the day. And we have a solution for that as well. That's actually going to be our LegioMix. Okay, so not only can our LegioMix, it's a great mixing valve first and foremost. It's ASSE 1017, so it's going to comply with all the standards. It's low lead and everything else, but it has the ability to do that thermal disinfection cycle if you have an application for it. You don't have to use it if you don't want to, and by default, all the thermal disinfection functions are off. But it also has the ability to eliminate recirc creep as well and maintain that temperature at a very safe temperature. And the reason why we can eliminate recirc creep is the fact that we're using a three-way ball valve inside of here. So a three-way ball valve obviously has the ability to completely close off one side or the other. So that way you're eliminating the idea that you can add more heat to the loop than what it actually needs. So really cool product we've had out for a few years now in the North American market. It's been in the European markets, South America, and the Middle Eastern markets for almost 2 decades. Available in 3/4 inch through 3-inch sizes. And I will caution you very highly on this. If you are using a three-way ball valve assembly, you're going to get really high flow rates with really low pressure drops. Okay, so it's very easy in a lot of cases to oversize these mixing valves, and I can't stress it enough. And most of you guys are probably, if you're on this webinar, you're trying to continue your education, you're trying to do best practices and everything else. And best practice with sizing these mixing valves is to size them based on the flow rate and pressure drop going through them, not not by pipe size. Okay, so if you are sizing by pipe size, I can just about guarantee you're going to oversize this mixing valve. And if you do oversize the mixing valve, the one thing you're going to run into is that you're going to pay more, first and foremost, pay for something you don't really need. But then you're also going to have issues with the minimum flow requirements. So if you got a 2-inch pipe size and you're running 50 gallons a minute through there, you don't really need a 2-inch valve. You could really get away with 1.25 inch that has a design flow rate of 66 gallons per minute and just neck down to it. So the idea here is you want to size it based on flow and size it based on pressure drop. And, again, if you do oversize it, you're going to run into minimum flow requirements. Now, what happens if you don't meet minimum flow requirements on any mixing valve? It doesn't matter if it's ours or anybody else's. We all have minimum flow requirements. I will tell you that they don't blow up. They don't, cause big catastrophic issues, but you're going to get unstable outlet temperatures. It could be too hot. It could be too cold. It could hunt and things like that. And that minimum flow requirement is there to make sure that you maintain velocity in the body of the mixing valve and maintain a good turbulent mixture in there so the sensor doesn't see all hot or see all cold. And that way it can regulate temperature very, very well. So again, really high flow rates, really low pressure drops. You'll notice that we have all of this published in our literature as far as minimum flows, design flows, maximums. Now, minimum flow requirements, don't be terribly afraid of these, because if you are running constant recirc, which we're always going to recommend to prevent stagnant water, again, the idea of growing more and more Legionella bacteria, if you do meet minimum flow requirements with your recirc, then you're not going to have any issues with temperature stability coming out of the mixing valve, which is great. But one other cool thing that we have to help out those people with the really harsh water conditions is a function called anti-clog. Anti-clog is basically a work of art here between the control and the valve and the actuator here. And what it does is it actually will do a full stroke of the ball inside the valve assembly in both directions. It'll do a stroke in both directions once a day. So if you do have any debris or scaling on that ball, it's going to clean it off. And I think that's really great. And obviously, if you even look at this 3-way ball valve assembly, there's next to nothing inside of here. So the idea of scaling and debris and catching a bunch of junk in there, it's going to be at pretty much a minimum anyways, but the anti-clog function will make it that much better. So really great valve for harsh water conditions. We also have the ability to connect up to building management systems. And this is something, you start talking about building management systems, this is something you're not going to be able to do with a thermostatic mixing valve. And this is where we're seeing a lot more of the demand for the electronic mixing valves is the idea that they want to connect it to building management. They want to adjust things on the fly. They want to see what's going on and so on and so forth. Another really cool thing that sets an electronic mixing valve apart from a thermostatic mixing valve is, especially with ours here, we have the ability through our control to do data logging. So the idea that you can log days, times, temperatures, and you can verify all this and protect yourselves as a business to make sure that you're sending out the right temperature water. So some really cool things here. And not last but not least, between the control, the actuator, and the valve, they are completely standalone. So you don't have to connect it up to building management systems. And the other really neat thing about being standalone is that you can completely set them up and adjust everything as needed through the control without bringing a laptop on site. There are some of our competitors in this market that do require you to bring in a laptop on site in order to make adjustments or setting changes and things like that, which I think is a big hindrance in a lot of cases to most mechanical contractors. So like I said, really cool product here. Then the next guy that we brought to the market about a couple years ago, we try to make things as easy as possible, is our stations. These are our pre-rack stations here. The idea that all the piping is finished, check valves in all the right places, valves, isolation valves in all the right places is a great thing. But what I think is better than anything here is the idea that everything is pre-wired. So the actuator, the sensors, and what you don't see in this picture here is that we have a 20-foot cord that comes with it with a plug-in transformer. So it pretty much keeps the mechanicals and the plumbers out of the control, which is honestly, and I'm going to be brutally honest with you here, this is where most of our problems have come into play with this particular product, is the idea that guys that are used to putting pipes together are now putting wiring together in a lot of cases, or an electrician that's not familiar with the product. And then all of a sudden they let the magic smoke out. And coming from the service side of the industry, once you let the magic smoke out, you're not putting it back in there, and then all of a sudden you need a new control. So the idea of everything being pre-wired, I think, is fantastic, and it makes the job so much easier. You hang it on the wall, you make your piping connections, and you turn it on. It's as simple as can be. So really cool product, and we are going to be offering larger sizes here in the coming months. So so that's just what we have to offer right now. But in the end, think about the big picture. If you know about Caleffi as a company, you know, we're an Italian manufacturer of really high quality components. You might know us and even by our name, Hydronic Solutions, okay? That's where we really cut our teeth in the North American market. And so we've got a lot of really cool products for your heating systems out there, but we also have, and we're coming out with more and more as time goes on, more and more plumbing products. So if you're thinking about plumbing applications, definitely think about us. You know, we've got the front end point of distribution ASSC 1017 mixing valves. We've got your anti-scald point of use mixing valves, and we've also got balancing valves as well. This little guy right down here is a really cool one, our thermal balancing valve. So it's actually balancing a domestic hot water recirc based on temperature as opposed to a specific flow rate. We also have pressure reducing valves as well. I mean, lots of really cool stuff. So so like I said, keep an eye out for us. Even in the plumbing sector, we're going to be bringing out more and more products. And in the spirit of education, I just wanted to kind of let you know about, and Greg already mentioned it, one of the big things is our Coffee with Caleffi webinars, completely free webinars. You can log in, you can watch the webinar live. If you do attend live, you do get a certificate of attendance, so you can actually use that for professional development hours if you can. We also have our Hydronics technical journals as well. So the technical journals are basically like a free textbook, you know, and obviously give us a call if you have any questions. We're always here to help between the guys at Wrath, who are incredibly smart guys, and they're always willing to help you guys out the best they can. You can call us at Caleffi too. You know, times are a little weird right now, and a lot of the office personnel at our facility in Milwaukee, Wisconsin are working from home, but we're still going full bore at this point. You know, it's just kind of a different way of doing things. So from there, I mentioned Hydronics, our technical journal. A lot of the stuff that we talked about here today, and this is actually a handout. I appreciate you did that, Greg. Within the GoToWebinar software there, you should see a little tab that says handouts. You can download these as a PDF right from our GoToWebinar. You can download them as a PDF right from our website as well. Awesome resource on these guys. Talks really in depth about the thermal disinfection process and balancing for domestic hot water recirc and in issue number 21. Great free resource. And then last but not least, let me see if I can get the clicker to work there. For you guys that are doing any design and engineering work, we do have a lot of great resources on our website, right from our normal website. You don't have to go to a special website and log in with your special username and password or give away your firstborn child to get any drawings or anything like that. You can go right on our website, download all the spec information. You have access to all our drawings on a particular product page. We also have a library of drawings here as well, 2D, 3D, BIM. The list goes on and on and on. So if you guys have any questions, obviously don't hesitate to give us a call, and I appreciate your time, and Greg, thanks for putting this on. I think I'll pass it back on to you.
All right, great. Thanks a lot, Cody. That was really a great presentation. You know, as I mentioned, Cody and Caleffi, I mean, they're just top notch. Everything he just pointed out with the whole Hydronics catalogs, I'm telling you, it's like an encyclopedia of information that you can understand. It's very well written. As he had mentioned, I put them in the handout, so download them. And you know, if you want a full catalog or any individual one, I mean, at the very least, if you don't want to even talk about any of this, reach out to us about that. We can get you that. I really urge it. It's great information. Anytime I'm curious about something, you know, you can Google around and try and find answers. I can almost guarantee the answer is in one of their catalogs. They also do these like 2 to 5 minute YouTube little clips on a lot of their products to understand the idiosyncrasies about them. So really great stuff. Just a tremendous resource. So I see a lot of questions are rolling in. I really appreciate them. Keep coming. Keep rolling them in. As I mentioned, though, we want to take a short little break real quick, you know, maybe about a minute, just let you guys vote here. So over the past handful of weeks, we've been putting out a couple of different charities. We've been trying to change them up a little bit. So, you know, Wrath Associates, like I said once, we really want to do our part during this pandemic. There's a lot of frontline people, first responders, but then there's also just charities who are doing a lot of good things and helping to donate money to the right places. So, Wrath wanted to do our part. We figure we'll just roll it into this whole thing and let you guys help us out. So, do us a favor. Vote, who do you guys want this money to go to? Again, it's $500 directly to them. We cut a check, nice and simple. Just want to do our part. So I see that, a handful of people are voting. We'll give it about another 30 seconds or so. Just keep the votes coming in. While you guys are doing that, a little reminder, again, there's the handouts and then there's the questions. So make sure that any questions you have, don't hesitate, throw it out there and we'll address it. And then, of course, if you want a one-on-one session with someone from Wrath Associates, we could go as deep into detail as you want. We could get together with you and your team. We can do a webinar, or when this whole thing blows over, we can get together in person, hopefully without even masks. That would be nice. And we can discuss things, anything that you want in further detail. So I just closed out the poll. Thank you everyone for voting, and it looks like it was really close actually. It was 54 to 46%, and it looks like everyone went with the winner is the COVID-19 Emergency Relief Fund. So thanks again for everyone for voting. We're going to get that check out today or tomorrow. And so anyway, without further ado, let's get back over to the questions. And I believe we have Bruce and Rich on the line. They're going to moderate these questions. Guys, can you hear me there?
Yeah, we got you.
All right,
Cody,
why don't you take it away?
For you. I have a question for you from Jim Hedden. We install indirects with either boiler or Techmar controls. This keeps the water temp relatively low. General rule of thumb, every 20 degrees you raise the water temp, you double the corrosivity in the tank. How would you raise the temperature in the tank if so controlled?
So that's a great question, Jim. So the idea with the LEGIOMIX control is that inside of it we have a small handful of dry contact relays, and through the control, you have the ability to schedule the thermal disinfections, days of the week, times of the day, for how long, what temperatures, so on and so forth. But during that thermal disinfection process, we do have the ability, like I said, through those dry contact relays in order to do this. Now, this is where it does get a little bit tricky sometimes for some of the mechanical side. Usually what you're going to end up doing is, if you've got a storage tank, you're going to have a secondary aquastat on that storage tank that's going to be at a much higher temperature. So the idea there is that if you have a regular aquastat on there that's set to 130 or 140, you're going to have a second aquastat that's going to be set to 160 or 170. That second aquastat is going to be calling all the time, obviously, for heat from your boiler. But with that in mind, you're going to wire that second aquastat in series with our LEGIOMIX control. So when there is a call for thermal disinfection, our dry contact relay will close. The second aquastat will already be closed. It will take that boiler, ramp up that storage tank. Now, when you get into very specific controls, I can't really play that game right now with you, Jim. So I apologize for that one. But I have had other customers too where they use the dry contact to connect up to their building management system, if the building management system is controlling the temperature of the water and cycling the boilers and things like that. But if you wanted to go in depth a little bit more on a specific control or how you'd make that work, we can definitely do that offline. But like I said, the idea with the dry contacts is to make sure that, like I said, during normal operation, you're not running that tank at 180 degrees or 170 degrees. Like you said, you're gonna raise that corrosivity. You're gonna kill the tank, and obviously the guys that sell you tanks are gonna be really happy with that because you're going to be buying more tanks, but you want to make sure you get your life out of that tank for sure. So, normal operation, running at the normal temperature, go into thermal disinfection, kick it up, get that distribution temperature up, and then bring it back down as quickly as possible.
Cody, I have another question for you. When selecting the size of a mixing valve, you are supposed to get as close to the design size. How would you handle a flow rate of 190 GPM?
Perfect. That's a great question. So with that in mind, Greg, would you be able to, I don't know if I can go backwards in the slides to go to that recommended flow rates.
I think you can. Why don't you go ahead and just maybe you could just maybe tap the arrows?
Yep, I got my keys. There we go. Perfect. Okay, so this is a great question. So again, sizing is very important with any valve, especially mixing valves, because for many years, especially with thermostatics, it was very easy to undersize the mixing valve. And the obvious downsides to undersizing a mixing valve is that when you do reach demand flow rates or design flow rates, you're going to get really high pressure drops through that valve, and then all of a sudden you're going to get a lot of complaints that you're not getting the water flow that you need out of your fixtures. So, for example here, great question, get as close to the design size as possible. So say you've got 190 gallons per minute design flow rate in a building. Okay, so you look here, and our design flow rates are based on a 7.5 psi drop. Okay, so we've got our minimum flow rates, we've got our design flow rates at 7.5 psi drop. We've got a maximum flow rates which are at a 20 psi drop. So you always want to get as close to the design flow rate as possible. So when you look through here, you've got 190 as your design. Obviously an 1.5 inch is designed at 93, 2 inches designed at 131. But then you make that big jump up to 2.5, which is going to be 288. So what do you do about that? And that's a great question. So I will tell you, in a lot of cases, most of your design flow rates, if they're based on any type of a Hunter's curve, they're pretty generous. Okay, so you might be probably more apt to look at the 2-inch model here, even though the design flow rate is 131 in the 2-inch model. Your design flow rate for that particular application is 190. How often are you going to hit that? And we're still capable of handling that up to 215 gallons per minute. One thing you got to be careful of though is what pressure drop is acceptable in your building. Okay, obviously if you're hitting that 190, you're going to be close to that 20 psi drop, and if that's not acceptable, I totally get it. Another great thing to think about here is potentially doing parallel valves. Okay, parallel valves, if you were to take 2.5-inch models, that would get you really close to your 190 gallon per minute design. But I think the other great thing about this is that you're going to have redundancy as well. So say for example, if you've got 2 valves going out to a building and one does need to be serviced for whatever reason, and this doesn't apply just to our valve, it applies to anybody's valve, but if you've got any type of service necessary for one valve, you can still keep the building operational by having the other valve still up and going. This is especially critical in those buildings where you have really no control over who's using it and when, and like hotels, like hospitals, things like that, where a lot of these places are going to really require redundancy. So you could be a little bit courageous and go for that 2-inch, and chances are you're probably going to be okay. The redundant function is probably one. If you really wanted to go for it, like I said, the 2.5-inch model would definitely cover it, but then you wouldn't have the redundancy either, and you're looking at a little bit more costs. So there's a lot of things to wrestle with there, but it's a great question, and I guess it just really depends on the application. So.
Hey, Cody, I have another question here. Is there any protection to ensure that the sanitizing cycle does not go longer, or a system over temperature indicator?
That's a great question. So within the control, there really isn't going to be any secondary protection. The scheduling function, what you're doing is you're picking out specific days and specific times of the day and specific durations. So the idea there is that even if your storage tank ramps up and it doesn't come back down again for whatever reason, the mixing valve should still be able to actually control that back down to whatever your distribution temperature needs to be. So even if you ramp that tank up to 180 and you do your thermal disinfection at 160, the idea there is that even after that duration is done, it's going to come back down to your normal source there. That is a great question. I know there are some manufacturers on the market that actually have an over temperature solenoid function, where if it goes over a certain temperature for a certain duration, it'll actually shut off hot water flow to a building. And that is something that we're considering for the future in the next generation of controls, but it's not something that we have currently. We haven't really run into a whole lot of issues with it as far as being knocked out of specs and things like that due to that, but there are a very valid question nonetheless. Like I said, no secondary safeties to make sure of that, but like I said, the control, as long as that's functioning properly still, even if the tank is really high, it'll bring that temperature back down.
Cody, I got a bit of a technical question here for you. If the DHW demand is a thermistor to TECMAR, how do you jump over that?
That is exactly what I was talking about earlier with the idea of very specific controls and everything else. I do know there are some boilers out there that, if, for example, if they're using a resistor, a resistance-based temperature sensor, you could actually use an aquastat instead. The idea of either infinite resistance or no resistance whatsoever is going to simulate either really hot or really cold temperatures. And so the idea there is chances are you might still be able to use just a bang on, bang off kind of aquastat in those cases to control that temperature to bring it up again. But again, I'd have to, I'm a very technical guy, and I hope you guys can appreciate that I'm trying to dial back some of that at this point. But if you wanted to go offline about that, and definitely I'd be more than happy to indulge on that one. But I don't have a very specific answer for TECMAR in particular.
Hey, Cody, I got another one here. If you use parallel valves, how do you ensure proper piping to keep the temps and flows as per design?
Oh, that's a great question. Okay, so I'm sure a lot of designers and mechanical contractors out there on the line here are probably pretty well used to the idea of having multiple tanks, storage tanks, or multiple heat sources too, for that matter. So what you're using in those particular scenarios is very similar to what you're going to use in multiple valve scenarios. You're either going to do equal distance piping. And the idea with equal distance piping is that you're going to have the same head loss or the same pressure loss through each side. So you're going to basically guarantee equal flow. Or you could look into some form of reverse return type piping. So that way, first in, last out, last in, first out kind of thing. So it's definitely possible. I've got some kind of real blanket type diagrams that are pretty neat. But yeah, you definitely want to make sure you're getting equal flow. And even if you don't, I mean, it's really hard in a lot of cases to make sure that you've got equal flow rates through the valves. Even if you don't have exact equal flow rates through the valve, they're still going to function properly. And as long as they're pretty darn close, you're probably going to be okay.
Cody, quick question for you, kind of a two-part question. Can the control be remote mounted, and does the LegioMix have a battery backup?
Oh, great question. So the control can definitely be remote mounted. I mean, hundreds of feet away if necessary. I've seen it before where the control is in the building engineer's office and the valve is in the mechanical room. The idea there was to prevent tinkering, to make sure nobody else is screwing with the control when they really shouldn't be. The actuator on the LegioMix is a 24-volt floating actuator. So with that in mind, it's just a standard 24-volt control signal. So there's really no problem there with extending wires. All the sensors are going to be 10K ohm sensors. So again, by adding a couple hundred feet of 18 gauge wire, it'll change your temperature just a little bit because of the extra resistance, but it's so minimal that you're not even going to notice a difference. And then from there, battery backup. Within the control, we do have a backup, a battery in there for backing up settings. Okay, so if you do have a power outage for whatever reason, that battery in there will back up all the settings: date, time, location. If it's fully charged, that battery will actually back up the settings for about 2 weeks. Okay. Now, if this is a mission critical type application, say a hospital or whatever the case may be, and you can't do that. Now, obviously, those buildings are going to have probably a battery backup, or a generator type backup. And so you're going to have that transition. You're going to want to have the control on the generator backup. And if it is really incredibly mission critical, get the control on a UPS, an uninterruptible power supply. So that way that the loss of power, it'll transition to the battery backup or the UPS, and then it'll transition over to the generator. And then there will be no interruption in service whatsoever. But the battery backup, like I said, is just for settings, not to operate anything. Great question.
Hey, Cody, it's Greg. So just, I guess, a little clarification for even just for me. So in an application where it's just, powered, regularly, right? You just send 120 volts to it. If there is a power outage, does it fail at its most, recent position?
Correct. The actuator.
And also, I suppose, what would be any recommendation for protection to people if there was a power outage?
Sure. So again, power outage, you know, if you do have a power outage for whatever reason, the actuator, like I said, is a 24-volt floating control actuator, so it's going to fail in place. So wherever that happens to be. Now, if it is something that you wanted to bypass it for whatever reason, you can remove the actuator, and there's actually a slotted screw or a slotted in the top of the valve stem to where you can actually operate the valve manually if you really wanted to. Now, as far as, again, any type of emergency functions that you want to try and make sure that it stays running, like I said, the UPS or a generator type system is definitely going to be in the mix there. Now, if you are talking like larger commercial buildings, maybe some mid-rise or high-rise buildings and things like that, you're going to have a lot of other stuff go down in that building that's going to go down too, along with the LEGIOMIX, say booster pumps and things like that. So I mean, you're not only going to have an issue with water temperature, but you're going to have an issue with just water, period. But with that in mind, yeah, like I said, definitely want to make sure you get it on a UPS and a backup system.
Hey, Cody. Of course, in this day right now, we're dealing with COVID-19. And the question is really about, like, if residents come home while the sanitization mode is in operation, how will that affect the performance of, I guess, the hand washing stations or sinks and the valve?
Great question. So if you're designing this system appropriately, again, you need to have point of use mixing to make sure that you're protecting those occupants during that thermal disinfection cycle. And this is not something new. You know, the idea of redundant valves in a system. You know, most of your healthcare facilities are requiring point of use mixing valves anyways. And you know, to go back to the idea of Legionella and Legionnaire's disease, Legionnaire's disease is the biggest problem with Legionnaires is for those that already have compromised immune systems, which again is going to be hospitals, healthcare facilities, nursing homes, things like that. But as far as how it will actually affect the whole system if people come home and start washing hands and taking showers, it really shouldn't. Okay, like I said, if you've got the secondary mixing valves, the ASSE 1070 point of use and 1016 temperature, thermal-based shower valves, things like that, you're going to be protecting those occupants. Now, obviously, by drawing off of the distribution system, you're going to be bringing in more fresh water into the system. So obviously, your boiler's got to have enough oomph behind it to keep that temperature up in the storage tank and keep up that distribution temperature as well. So so it really shouldn't affect the people using it. There really shouldn't be nothing there to affect them as long as you're designing it appropriately. But if you're bringing in massive amounts of cold water, the boiler might have a little trouble keeping up at that much higher temperature, which again, the idea behind the thermal disinfection is to do it during the times of very little or no demand. So that way, you know, the boiler does keep up.
Cody, real quick, on our mixing valve as well as any of our competitors, are there any calibrations that are required?
Not really. I mean, the valve is operated by the control. The control is looking at the sensors. You can kind of see it here, the mixed outlet sensor right here in the body of the valve. Like I said, those are 10K ohm sensors. Really, the only issues that I've seen so far at this point where a valve is a little bit out of whack is because of loose wiring connections or a cut wire, for example, where it will show an open or a short on the control, but there's really no calibrations necessary, no.
Hey, Cody, it's Greg, and I have actually another question. So you obviously chose, or Caleffi chose, to go with a ball valve style, whereas a lot of the competition is using, I believe, a globe valve. Could you just maybe go into the benefits of the ball valve style?
Yeah, for sure. So ball valves, obviously, traditionally not. Ball valves are not traditionally the best way of controlling flow, but temperature in this case is definitely something we can do. And so when you look at globe valves, they might have a little bit more definition in their stroke and everything else. But what I always remind people of is that our valve, as well as anybody else's globe valve, for example, they're both listed to the same standard, ASSE 1017, which is a standard to make sure of the accuracy of the valve, plus or minus a few degrees at whatever flow rates that you're looking for. So everything that we have to offer is listed to ASSE 1017, so it's going to be just as accurate as the next guy per the standard, and it's going to do just great.
And great. I also have a question here about maintenance. If, let's say you're doing maintenance on a building in the middle of the night because nobody's there and it's going to go into sanitization mode, is there a way to override that on the unit?
Well, that's a great question. I know on the control, there is a function, there's a button on the front of it called shock where you can actually initiate a thermal disinfection manually. With the scheduled thermal disinfections, I do believe there is a way to override that. But I can't remember the specific button sequence. I'd have to look into that one. That's a great question on that one. I can't remember specifically how that worked, but I know with the manual thermal disinfection cycle, you can definitely override that and shut it off if you do turn it on or need to want it off again. But it's the scheduled one that I can't remember right off the top of my head. That's a great question though.
Cody, this is something that you and I have spoke about, but you are not required to use the thermal disinfection cycle, correct?
Correct. Yeah. I mean, when I have more than 20 minutes to do these webinars, I really like to impress on people that this is a mixing valve first and foremost, and it's a great mixing valve with the LegioMix. And the thermal disinfection functions that are on there, they're just a nice add-on. You know, they're there if you need them, but you know, I'd probably go out on a limb and say 90% of our applications of this mixing valve do not use thermal disinfection. You know, it's a great mixing valve. It can connect up to the building management systems. It can do data logging. We actually had it was a prison system in Florida that they installed like 16 of these things. And the biggest selling point for them wasn't that it could connect up to building management. It wasn't that it could do all this other stuff. That they weren't doing thermal disinfection. They wanted the data logging. Okay, it's the funniest story, and it makes me think of how great America is. It's that they were running into issues where inmates were suing the prison system because they were getting scalded. Okay, and now they have these LegioMixes in that they're doing the data logging, and they can use that information to combat those lawsuits to keep them from getting sued. Which again, wild ways of doing things here, but it doesn't have to be thermal disinfection. It can be used for all these other things too.
Hey Cody, it's Greg again. I just kind of wanted to piggyback off my question before. So your answer to the ball valve versus globe valve was, essentially, we all kind of comply to the same standards. But I think there's actually a couple more benefits to utilizing the ball valve, right? You don't have to take it apart, less maintenance. It's easier. I mean, if you had to take that, so why don't you go ahead and maybe list the handful? I just want to make sure that's understood.
Yeah, so I mean, with a globe valve, in a lot of cases, you're going to have a lot more issues with scaling and seizing and things like that, because typically that globe valve is going to be run by some type of a stepper motor or something like that on the very top of it, and so the idea that it can go full stroke, full hot to full cold, and the idea is it could clean off that stem that's being controlled by the stepper motor, but you're still always going to have that debris and potential for scaling on the actual disc that's doing the opening and closing to each side, and so you might have a lot of issues there. And also in a lot of cases, those stepper motors have some pretty big clearance requirements as well. Now with our ball valve, like I said, the idea there is that there's pretty much nothing in there to scale up to begin with. And then, like I said, between that and the anti-clog function that we have to offer with the control, which that anti-clog function, it is on by default, but you can turn it off. Okay, so if you don't want the anti-clog function on for whatever reason, you can turn it off. But between those two items, I mean, there's pretty much maintenance is kept to a minimum. So if one of our biggest demands for this valve when we first brought it to market, it was not specified design build type projects, and I was really surprised by that. It was those guys that have a building that's 30 years old and they've been replacing mixing valves every year or gutting and cleaning mixing valves twice a year for the entire life of that building, and they were just looking for something more robust that can handle harsh water conditions without having to be maintained as regularly and have all the issues that some of the thermostatics will have. On top of that, the idea that a ball valve is, again, incredible flow rates with really low pressure drops. So when you talk about sizing the valve, I mean, you're getting the best bang for your buck out of this valve as long as it's sized appropriately, for sure. So.
Yeah, and Cody, I remember too that the actuator and the whole installation requires only about 6 or 8 inches of clearance around the valve compared to a lot of the competitors as well, right?
Yep.
particularly on the top side.
Yep. So when you look at like our pre-racked stations, obviously you've got to have some room in there, but we do sell the valve, actuator, and control as just kind of a standalone system, so you can pipe it in yourself. And like you said, man, I mean, there's very little clearance required to be able to maintain this guy. The actuator comes off; it's got like a little cotter key holding the actuator to the valve. You pull the cotter key, you need about an inch of clearance to get that actuator off. About the only thing I would say with installation is just make sure that, because that actuator, you don't want the actuator upside down. You don't want it on the bottom side of the valve. It's not hermetically sealed. So if you do get water going up through the stem or off of a joint somewhere, you could actually cause issues with the actuator. But really, as long as it's kept at, the 9 o'clock, 3 o'clock, or 12 o'clock positions, you're going to be in good shape.
Yeah, Cody, I have an interesting question here that I don't think I've ever really thought about it, but do we need to maintain a temperature differential between the tank and the mixed temperature so that way the valve can mix the temperature?
It's a great question. We do not have a minimum temperature difference from hot inlet to mixed outlet. Okay, this is something that you're going to see on every single thermostatic mixing valve, though. So, I talked earlier about how thermostatic mixing valves cannot completely close off the hot or the cold inlet, and that's the reasoning behind that temperature difference from hot inlet to mixed outlet. So if, say, you desire to have 120 distribution temperature, but your tank is 120 on a thermostatic mixing valve application, you're still going to have some cold coming into the distribution. So your 120 tank is going to then get mixed down to 115 or 110 or 105 or somewhere lower than what you desire it to be. So the idea with the ball valve is that it can completely close off the cold side if it needs to. But during normal operation, you definitely want to have some differential there, so that way you can get some good control and everything like that through the valve. But if it does come down to it and your tank really gets drawn down quite a bit, like I said, it can completely close off the cold side and send 120 right from the tank out to the fixtures, no problem.
I got another question here for you, Cody. It says, maybe not a fair question. How does the LegioMix compare to other mixing valves in terms of reliability?
Oh, that's a totally loaded question.
Sorry.
All right. So, I talked about reliability and durability and dealing with harsh water conditions and everything like that. But really, I think ours is going to, in an apples to apples scenario, I think ours is going to hold up really, really well. Now, like I said, this valve, we've had it in the North American market for a few years, but they've had it in the international market for almost 2 decades. Okay. We've sold literally tens of thousands of these valves worldwide, and we've had very little issues. Okay. Now, again, in an apples to apples kind of scenario, I think ours is going to hold up very well, if not better than pretty much anybody's out there. But it's really, really, really going to depend on how bad the water really is. Okay. And how bad the installation might be. The valve is pretty much bulletproof. I mean, when you start talking about controls and actuators and things like that too, I mean, that's where a lot of variables come into play with how well it's wired, how clean the power is coming into the building, things like that.
And I got one more here for you, Cody. What is the payback if you install this in a 2-family house or commercial building based on energy savings versus standard domestic hot water heater pushing 140 or higher water normally?
That's a interesting question. I don't think payback's necessarily the best term to be using on that one. I think you're going to get safer operation of your building. I think you're going to be protecting the occupants of those buildings, whether it be with the control of the water temperature coming out of the LegioMix or the ability to do thermal disinfection. Now, if you are controlling at a lower temperature through your distribution system, you're going to have less heat being taken away to ambient just due to heat loss in your distribution system. So I mean, obviously, if your ambient in the building is 70 and your pipe is 120 versus 140, you're going to have more heat loss off of a 140-degree pipe than you would a 120-degree pipe. But I don't think payback is necessarily the right word. I think the idea is, again, safety and protection of the occupants, I think, is first and foremost.
Gotcha. Thank you. Let me see, what else do
Oh,
we?
I got a question about the data. How long does the LegioMix store the data, and how often do you have to, I guess, or how can you back it up or get it off of the unit?
That's a great question. So like I mentioned before, we do have the ability to do data logging. The data logging in the control is 40 days. And it's a first in, first out kind of data logging. So after 40 days, it will take and it'll rewrite the first day with the next day, and then they'll rewrite the second day with the next day, and so on and so forth. So it'll do 40 days. With the control, you do have the ability, if you have it connected up to building management systems, to get it off of the control. Okay, and I know too, like a lot of building management systems will do data logging right off the bat there too. So if you do have this connected to building management systems, then you could use the building management system to log all that data as well. So you can either access it through the control or through a building management system. There's really no way to get the data off of it without connecting it to building management systems if you are looking to remove it, but you can still access it all and see it all right from the control.
Yeah, also, I got another question about pressure, system pressure. So, is this thing capable of being in a 40-story building, or do you need to have a strategy to deal with the pressures in the system?
So we do definitely have pressure requirements. As far as the valve is concerned, we can handle up to 230 psi. Okay, now most of your valves are going to have a kind of a static pressure capability, and it's also going to have an operational pressure capability. And so with our valve, we do have the ability to do that up to 230, but normal max working pressure for the dynamic the changing capabilities or the moving capabilities of the valve is 150 psi. So if you are looking at large high-rise buildings, it is something that you do need to take into account. If you're doing all your domestic hot water heating at a suite on the roof, obviously it's not a problem because your pressure is going to be much lower. But if you're doing everything from the bottom of the building, then that's something that you need to address. And I do know there's very few valves out there that can handle those incredible high pressures. That's a very different market indeed. But we can definitely handle the mid rises for sure. And if you're doing the high rises, you just got to make sure that you're below that 150.
Guys, just a quick reminder, keep the questions rolling in. We'll certainly answer and address as many as we can, and we really appreciate your time and spending it with us. Cody, that brings me to my next question. With data logging, can you adapt a flash drive to save data longer, or is there a way to collect data in an office nearby?
No. Like I said, the idea with the data logging is that it's all on the control. You can get the data through the building management system if you connect it up to building management, but there's no way to connect a flash drive. Like I said, this is a product that it's not something. I always try to remind people that as a company, Caleffi is very large, but we're still very adaptable. And we've actually been having conversations even after just 3 years of having this product in our market. So this product, when we brought it to our market, it was kind of an adaptation of the European products. Okay, now obviously some of the demands and the requirements to work in the European market are very different than what we have here, and so it's definitely something we can take into account for potentially the next generation of controls, specifically for the North American market. Is the idea of maybe connecting a flash drive, maybe downloading it as a comma separated file or a tab separated file, so you can load it up into Excel and things like that. I think that would be a great idea, but it's just not quite there yet. So like I said, you're either viewing it directly on the control or you're connecting it up to building management systems.
Hey, Cody, I have a question. It comes up in the New York market that they require us to shut off the recirc pump at like 2 a.m. or 3 a.m. when nobody's using the building. Is that something that you guys comply with, or is there an issue with that?
So under normal circumstances, our control is not going to be the one telling the recirc system to turn on and off. Under every scenario, I'm always going to recommend the idea of constant circulation in a domestic hot water recirc system. And this goes back to the idea of warm, stagnant water is going to breed Legionella bacteria. Okay, so if you keep the water moving, okay, not stagnant, you're going to limit the amount of bacterial growth in there. However, we do have some of those jurisdictions. New York is one of them. California is another one of them, where they are requiring you to have either on an aquastat or some form of a timer system. So my greatest response to that is sooner or later, the codes requiring that are going to catch up with the fact that safety is going to trump energy savings any day of the week. There's actually a direct quote from OSHA that basically comes out and condemns the use of aquastats and timers in these buildings on domestic hot water recirc, specifically because of the fact that warm stagnant water breeds Legionella bacteria. And if you look at any of our codes, our safety code, or any of our codes for building these buildings, they're all based around safety. Energy is a great thing to save, but at what expense? Obviously, you need to make sure. So I'm very certain that one day, like I said, safety will catch up, and the idea of constant circulation will always be there. But if you do have a timer for whatever reason on there, and you are doing, say, thermal disinfection, we do have a dry contact relay. It can be used basically as a pilot relay, that during thermal disinfection, it will kick that circulator back on, okay? But it's not meant to control the circulator all the time. It's only just there to make sure that the circulator's on during thermal disinfection. Now, I'll tell you a little trick. I talked to a guy in California one time, and he was telling me about this facility he was working in, and he going through his whole scenario, we were talking, and he said that he was running constant circulation. And I said, whoa. I said, hold on here a second. I said, California is required to have it either on an aquastat or a timer. I said, how are you running constant circulation in this building? And he goes, oh, we have an aquastat. And I said, okay, great. I said, what's it set to? I said, he goes, that's the great thing, is they don't tell you what temperature to set it to. And I said, oh, so he's got an aquastat. He's making the inspector happy, but he's got that aquastat cranked to like 200 degrees, so it never shuts off.
There's always room in between those rules, right?
Yeah, there's definitely a gray area, that's for sure. And it made me laugh quite a bit. So if you need to work your way around that inspector a little bit, there's definitely ways to do that.
So also the temperature settings, or when you're setting up the gauge on this in the temperatures, is it in Celsius or is it in Fahrenheit?
So, like I said, this control was adapted from the European market, and so it can actually show in Celsius or Fahrenheit, okay? On the control, you can barely see it right here on this particular slide. There's two little LED displays, or LCD displays up here, that will show you temperature. The thing is that there are only two characters, okay? So 2 characters works great for Celsius, but it doesn't work so great for Fahrenheit. So when we adapted this control to the North American market, we actually put all the temperatures for mixed outlet and then return temperature sensors right here in this big screen. That's another one of those things that we're looking to change for that North American market in the next generation in controls. But we do have the ability to do both. So.
Okay, great, awesome.
All right, guys. So yeah, so it's 11 o'clock. We've been going for a good hour. So I think we hit just about all the questions on here. Anything we didn't address, we'll touch base with you individually. So I just want to thank Cody for coming on and doing this presentation. It was really great. He answered so many wonderful questions here. And I guess as a reminder to everyone, this webinar was recorded, and it will be up on our Rath Associates YouTube channel. So make sure you check that out. We have 3 other videos that we had done in the past 3 weeks. And of course, we have one coming up next week as well. We're still fine-tuning what that presentation will be, but rest assured we'll have one next week. So the one final housekeeping thing, as you guys sign out of this event, there is a little survey, so basically, if you're interested in being followed up with on this topic or any topic that we've discussed or anything at all, just to make sure you say yes. We appreciate your responses to that. And if you don't want to be contacted, just click no. That's fine too. So I guess, Cody, do you have any final thoughts? Sorry to put you on the spot, but any final thoughts before people log out?
No, definitely. Everybody just stay safe, stay healthy, and hopefully business is doing well for everybody. And like Greg said, if there's any questions on plumbing or hydronics, I mentioned before, our catalog is probably 80% hydronics. So if you're working at doing anything with heating a building with water or plumbing too, we can definitely help you with that. The only thing I'm going to say no to is wastewater activity. We deal with the freshwater side of things, but if you're dealing with anything plumbing related, as far as domestic water distribution and pressures and things like that, or hydronics, we can help you out the best we can. So don't hesitate to reach out.
Great. Thanks a lot, Cody. All right. Thank you, everybody, for joining on. Thank you, Bruce and Rich, as well, for helping out with the questions there. And we look forward to seeing you guys on next week. So everyone take care. Have a great day and a great weekend. Bye-bye.
Bye.
Bye.